The Technical University of Liberec is one of the leading universities in Central Europe, focused on the research of nanofibers and nanomaterials. Part of the university is the Institute for Nanomaterials, Advanced Technologies and Innovation. Highly equipped laboratories allow research of different aspects of nanomaterials within several departments of the institute. The Department of Advanced Materials, amongst other things, deals with research and development in the field of nanoparticles. We focus on the preparation of nanoparticle-based stable colloids. The ChemSpeed SLT100 platform allows the development of nanocolloid formulations using the combinatorial chemistry approach. The robotic apparatus allows parallel synthesis in 32 reactors simultaneously. The reactions take place under reflux with simultaneous control of external conditions. Automated technology enables screening of synthesis parameters that has an impact on the application potential of nanoparticle systems. We use the nano-indentation tester mainly for the measurement of thin films, in our case from 100 nanometers. These are mainly vacuum-steamed, sputtered or chemically applied layers. When measuring with a nano-indentation tester, the indenter load can be regulated up to 500 millinewtons. The indentation depth can be controlled up to 200 nanometers. To maintain the geometric similarity of impressions of different sizes, a triangular diamond pyramid according to Berkovich is used, which is not loaded by a common edge. This will ensure that the depth of the impression will be about 10% of the total thickness of the examined layer, and the measurement of hardness and other parameters will not be affected by the properties of the substrate. Technical ceramics is world-renowned as an advanced material with excellent properties like hardness, compression strength, corrosion resistance and electro-resistance. Some of them are unique for their biocompatibility and for the number of applications within the human body. One of the downsides of usage of such a sophisticated material is scant knowledge of the production and shaping process. One of the targets of our investigation was to remove the present barrier between the designer and technologist for ceramics fabrication. One goal of our work is the development of a material and technology of extrusion to build the flexible ceramic filament for biomedical application. Another goal was to adapt the standard RepRap printer for the material we use. The Plasma Treatment Laboratory is equipped with reactors for low-pressure plasma generated by direct current, radio frequency or microwave sources. Plasma-assisted chemical or physical processes are used for research and development of thin films on a variety of materials. Their purpose is, for example, to increase hardness, environmental resistance, reduce the coefficient of friction, reduce or increase surface tension, ensure biocompatibility of treated materials, and others.